Welcome to the Explainer. So today we're doing a deep dive into a really fascinating yet almost entirely hidden problem in the world of artificial intelligence. Basically, why do perfectly trained machine learning models get sick over time? Think of your data as the lifeblood of your AI. When that lifeblood changes, we get what's called data drift, which is honestly the silent model killer.
It really all boils down to one massive mystery. Why do perfectly trained AI models fail in the real world? You deploy this pristine, highly accurate model, and then it just kind of degrades. It's exactly like a patient that was perfectly healthy yesterday, but gets sick today just because their environment changed. The real world is incredibly dynamic, but your trained model? Well, that's just a static snapshot of the past.
Okay, let's actually define what's going on here. Data drift refers to changes in the statistical properties of your data over time, which ultimately tanks your model's performance. It is a massive challenge in real-world systems. And here's the kicker. While not all drifts require an immediate retraining of your model, every single type absolutely requires monitoring. If you aren't tracking it, you are quite literally flying blind. All right, here's our game plan for today. We're going to look at the silent model killer, break down the 4 specific types of data drift, explore some diagnostic tests and tools, and then wrap up by building an automated monitoring system using AWS. Part 1. The silent model killer. Make no mistake, ignoring the impacts of data drift isn't just some theoretical academic issue. It is a direct, immediate threat to your revenue, your system accuracy, and most importantly, your users' trust. Moving right along to Part 2, 4 types of data drift. Let's break down the specific variants of this illness so we know exactly what symptoms to look for. First up, we have the 2 most common variants. On one side, there's covariate drift, also known as feature drift. This is where the distribution of your input features changes, but their relationship to the target stays exactly the same. Think of it like a sudden wave of mobile users changing your overall click rates. On the flip side, we have concept drift. Here, the input data looks exactly the same, but the rules of the game have completely changed. Spammers figuring out how to sneak past your filters is a classic example. The features haven't changed, but what they mean has completely flipped. To put concept drift into perspective, our source material has this absolutely brilliant example. Think about users searching for the word Wuhan pre- and post-COVID. Before 2020, they were probably looking for travel guides or local geography. After, they were definitely looking for news or health data. The input text, that exact word, was totally identical, but a massive external event completely shattered the relationship between the input features and the prediction. Okay, variant number 3 is prior probability drift, which is really just a fancy way of saying label drift. Imagine a fraud detection system that suddenly sees a massive spike in fraudulent labels. The actual underlying user behavior might not have changed at all, but maybe the reporting mechanism got way better, so the distribution of your target variable itself shifts. And that brings us to the final and honestly the trickiest variant, feature interaction drift. This is where the relationships between multiple different features change, even if they look perfectly fine on their own. Like, imagine trying to predict house prices. The correlation between a home's square footage and its location could suddenly shift because a new tech hub gets built in a specific neighborhood. The individual stats look normal, but how they interact together? Totally different.
Part 3. Diagnostic tests and tools. Time to put on our lab coats and look at how we actually detect this stuff in the real world.
So the real trick here is knowing exactly which mathematical tool to pull out. A massive heavyweight in the space is the Kolmogorov-Smirnov or KS test. It's this brilliant non-parametric test that measures the maximum absolute difference between the cumulative distribution functions of 2 datasets. And fun fact from our sources, Netflix actually uses this exact test to monitor their own drift. You just compare your historical training data to your recent live data. If that difference exceeds your threshold, boom, you officially flag the drift.
But hey, the KS test isn't the only tool we've got. You also have the chi-square test, which is absolutely perfect for sniffing out label drift in categorical data. Then there's the Jensen-Shannon divergence. That one gives you a really clean similarity score between 0 and 1. And if you're dealing with continuous variables like fluctuating product prices, you'd use the Earth mover's distance, which literally quantifies the exact amount of effort it takes to transform one distribution into another. Pretty cool, right?
Now, translating all that hardcore math into actual open-source Python libraries really depends entirely on what kind of data you're dealing with. If you've got tabular data and you want pre-built visuals, evidently AI is your best friend.
Working with images or raw text, you're going to want Alibi Detect for that, since it handles non-tabular data beautifully. And if you're operating in a super fast, real-time streaming environment, a library like River is perfect because it uses adaptive learning to handle sudden changes on the fly.
Part 4. Automated monitoring with AWS. Having the right tools is great and all, but now it is time to actually build our automated immune system.
Let's meet the core cast of AWS services that make up this immune system. First up, SageMaker Model Monitor. This is your detector. It's constantly checking live data against your baseline constraints. When it spots something weird, Amazon CloudWatch steps in as the alarm system. Then, Amazon Event Bridge acts like the nervous system, routing that alarm to exactly where it needs to go. And finally, AWS Lambda is the healer. It executes the custom workflow to fix the issue or trigger a model retraining. So let's put it all together. Imagine a wave of demographic drift hits your live customer data. Here's exactly how the workflow plays out. Step 1. Kinesis streams the incoming data and Glue preprocesses it. Step 2. SageMaker Model Monitor compares that fresh data against the baseline and spots the drift. Step 3. Event Bridge catches the alarm from CloudWatch and routes it. Step 4. Amazon SNS instantly fires off an email so your data science team knows what's up. But here's the best part. Step 5. A Lambda function is automatically triggered to start retraining the model. The system detects the disease and it administers the cure, literally all without human intervention.
I really want to leave you with this one provocative thought. Your models might be perfectly trained today, but are they prepared for tomorrow's data? The real world never ever stops changing, and having a static model in a dynamic world is a massive liability. But by understanding the different types of drift, running the right diagnostic tests, and building an automated immune system, you can ensure your AI stays just as sharp on day 100 as it was on day 1. Thanks so much for exploring this crucial challenge with me.